Good afternoon, friend. Today we have learned about Fresnel's half period zone. Fresnel's half period zones are called as division of plane wavelength. To find the resultant intensity at any point due to the wavefront, Fresnel has suggested to divide the wavefront into a number of half period elements or zones called as Fresnel's zone. Okay, so what? To find the resultant intensity at any point due to the wavefront, Fresnel has suggested to divide the wavefront into number of half elements called as or zones called as Fresnel's half period zones. Okay, are Fresnel's zones. Consider a plane wavefront A, B, C, D. Consider a plane wavefront ABCD of a monochromatic light perpendicular to the plane of the paper of wavelength lambda, propagating in the direction from left to right as shown in this figure, and let P be any point or external point at a distance B from O on the wavefront, where O is called as pole of the wavefront. What is O is called as? Pole of the wavefront. And the distance from the pole of the wavefront and external point P, it should be small p. With P as a center, suppose we consider P as a center, and spheres of radii equal to b plus lambda by 2, b plus twice lambda by 2, b plus thrice lambda 2, as b plus n lambda by 2 are drawn. These spheres cut out circular area of radii, that is OM1, OM2, OM3, dash OMN. Means we consider as a P as a center and of radii b plus lambda by 2, b plus twice lambda 2, a sphere, a circular sphere we can draw. Then this wavefront, it's cut into OM1 radii, OM2 radii, OM3 radii, OMN radii, etc. On the wavefront, these circular zones are called as half period zones. These circular zones are called as half period zones. Each zone differs from the neighbor by a phase difference of pi. Phase difference. So each half period zones are differ from its neighbor by a phase difference pi or lambda by 2. Okay. So phase difference कितना? Pi or lambda by 2. Sorry, phase difference pi and path difference. Path difference कितना होगा? Lambda by 2. The area enclosed by the first circle M1. The area enclosed by the first circle M1 is called as Fresnel first half period zone. So the area is covered by this zone, by first circle, is called as Fresnel first half period zone. This M2 covered this area, so this should be second half period zone. M3 covered, so this is the third. Okay, the area enclosed by the first circle M1 is called as Fresnel first half period zone, and the area between n minus 1th circle. So n minus 1th circle and nth circle is called as nth half period zones. So area between this, okay, n and n minus 1. So this area is called as n half period zone with respect to at point P. Okay. This is about Fresnel half period zone. Again I repeat it once again. Okay. So what to find the resultant intensity at any point due to the wavefront, the Fresnel has suggested to divide the wavefront into number of elements. Number of half period elements are zones called as Fresnel's zones. Consider a plane wavefront ABCD of a monochromatic light perpendicular to the plane of the paper of a wavelength lambda propagating in the direction from left to right as shown in this figure, and suppose let P be an external point at a distance of B from O on the wavefront, where O is the pole of the wavefront. With respect to point P, with P as a center, spheres of radii equal to B plus lambda by 2, B plus twice lambda by 2, B plus thrice lambda by 2, dash dash dash, plus B plus n lambda by 2, etc. are drawn. These pairs are cut. These pairs are cut out circular areas. These pairs are cut out circular areas of radii OM1, OM2, OM3, dash dash dash, OMN on the wavefront. These circular zones are called as half period zones. This circular zone is called as half period zones and half period elements. Each zone differs from its neighbor. Each zone differs from its neighbor by a phase difference pi or path difference lambda by 2. The area enclosed by the first circles, that is M1 circle, is called as Fresnel first half period zone, and area between n minus 1th circle and nth circle is called as nth half period zone with respect to point P. Okay. Now we calculate the radius expression, that is radius of half period zone. Okay. Now we solve the expression to find out the radius of half period zone. So let Rn be the Rn. So this distance is Rn. So Rn be the radius of the n circle. Radius of the n circle, that is half period zone. That is OMN. That is O, this point O and this point OMN equals to Rn. Okay. And B plus n lambda by 2 and B plus n lambda by 2. B plus n lambda by 2 be the distance of point P from MN. Okay. With the distance of the nth period zone from P. From this figure, we can say that this should be right angle triangle. Okay. So this MNP square equals to what? That is this OMN plus b square. Okay, therefore OMN square is nothing but MNP square minus b square. So Mn square is nothing but Rn square, and Mn plus p is nothing but b plus n lambda by 2. So this is b plus n lambda by 2 whole square minus b square. Okay. So I can write here. So what happened? So Rn square is equal to b square plus twice b n lambda by 2 plus n square lambda square divided by 4 minus b square. So this b square and this b square is cancelled out, and lambda, that is wavelength, is much less than b. So we neglect higher powers. Okay, neglect the higher power of lambda. So we neglecting the higher power terms of lambda. So we neglect this term, and what we get, that is Rn square is equal to twice b n lambda by 2. Rn square twice is equal to twice b n lambda by 2. This will get cancelled out. So Rn square is equal to n b lambda. So Rn is equal to under root of n b lambda. Okay. So this is the radius, nth radius of half period zones. From this equation we calculate the radius of half period zone. Okay. So thus the radii of first, second, third, etc. half period zones are. So what is the radius? That is first, second and third half radius of first, second and third half period zones कितनी होगी? So it should be R1 is equal to square root of b lambda, R2 is equal to twice b lambda, R3 is equal to twice b lambda. Okay, that's it. So therefore the radii are proportional. From this we can say that the radii are proportional to the square root of the natural number. From this equation we see that the radius, okay, the radii of half period zone is equal to the square root of natural number. Okay, so this is again, so we have to remember this term, that is Rn is equal to under root of n b lambda. Okay.